In this video, we will look at the rules for probability. So probability is a number between 0 and 1. That's our first rule of probability. Because it can be looked at as the proportion of times that a certain event can be expected to occur. So if the probability were more than 1, it would say that it would occur more than all of the time, which is impossible. And if it's less than 0, it would mean that it occurs less than no times, which again is impossible. So all probabilities are numbers between 0 and 1 inclusive. Probability rule number 2 tells us that if you put together all the possible things that can happen in a situation, together they have to have a probability of 1. So back to our example of flipping a coin, if you flip either heads or tails, those two probabilities have to add up to 1 because those are the only two things that can happen when you flip a coin. If it's less than or greater than 1, then you have a probability model that doesn't work, is inconsistent. Probability rule number 3 tells us that if two events have no outcomes in common, they are disjoint. And if they're disjoint, then the probability of one or the other happening is the sum of their individual probabilities. So here's a situation where we have disjoint events. A woman can be under 20, between 20 and 24, or 25 plus. But a woman can't be under 20 and 20 to 24 at the same time, so those are disjoint. And we know that all of those will have to add up to 1, or 100%, because that's also all the possibilities for ages. So by both rule 2 and 3, the percent that is 25 plus is 42%, or the probability that a woman is 25 plus is 42%. And probability rule number 4, is that the probability that an event does not occur is 1 minus the probability that the event does occur. Two examples here. If you believe that a defendant is the probability a defendant is guilty is 80%, then you also believe that it's 20% that he is not guilty. If the probability that a flight will be on time is 0.70, then the probability that it won't be on time is 0.30. So here's how we write the probability rules using mathematical notation. This is how we write the probability of event A. We put P for probability and then A in parentheses. Okay, so the first rule says the probability of any event A is between 0 and 1 inclusive. We call S a sample space, and then we say the probability of that sample space is 1. In other words, when you add up all the different possibilities, your probability has to equal 1. Rule 3 says if two events are disjoint, that means they have no outcomes in common. They can never occur together. So the probability of one or the other is the probability of one plus the probability of the other. We call that the addition rule for disjoint events. And for any event, the probability that does not occur is 1 minus the probability that it does occur. Now, discrete probabilities. Discrete means that there is a countable number of outcomes, a finite and countable number of outcomes. So you assign a probability to each individual outcome, where the probabilities are numbers between 0 and 1 and add up to 1. And the probability of any event is the sum of the probabilities of all the outcomes that make up that event. So an example, I had a slide in here for it, that's why it says previous slide. But the example is, say, rolling a 5 on 2 dice, okay? You can get that from a 1 and a 4, a 2 and a 3 and a 2, and a 4 and a 1. And if you add up the sum of all those probabilities, 1 over 36 is each probability. You add them all up, which is the same as multiplying by 4, and your probability ends up being 1/9. Now, continuous probabilities, we're talking about intervals. And we can't put a probability on each individual outcome because there's an infinite number of outcomes. And so we assign probabilities rather to intervals by areas under density curves. And this is what we were doing when we found the area under the normal curve. Any density curve has an area exactly 1 underneath it, which corresponds to the total probability of 1. Random number generators will give output spread uniformly across the interval from 0 to 1. So using a uniform distribution. So if you want to look at something like the probability of getting a random number that's less than or equal to 5 or greater than 8. Well, these are disjoint events because they can't occur at the same time. And if they're disjoint events, we can take the individual probabilities and we can add them up. So the probability that x is less than or equal to 0.5 on a uniform distribution from 0 to 1. So remember the uniform distribution from 0 to 1. And we're looking at the probability that it's less than 0.5, which is 0.5. And the probability that it's greater than 0.8, which is 0.2, we add those together, we get 0.7. The density curve used to assign probabilities to intervals is often the normal curve. And you'll see why, because normal curves come up a lot as we use large numbers of outcomes and do different things with sampling. And we use the standard normal probabilities in Table A, exactly what we were doing with proportions under the curve. So if you look back to Chapter 3 and all that we did there, that was really preparing you for this, using normal probability models. So if you want to convert the observed values into standardized scores, then you can find the probabilities from Table A. So remember, the table entry is always to the left of Z. So if you want the yellow shaded instead of the orange, that's going to be 1 minus whatever you got over here. Now, random variable is a variable whose value comes from something random happening. We often use capital letters for them, X and Y. And a normal, we would say that X, the random variable X, is distributed normal with mean mu and standard deviation sigma. That's what that means there. And a probability distribution of a random variable, it tells us what values it can take and how to assign probabilities to those values. So here it's telling you that the way you assign the probabilities to the values is based on the normal curve and taking z-scores and looking at area under the curve. Random variables with a finite list of possible outcomes are called discrete. If they can take on any value in an interval, they're called continuous. So discrete, you can count the outcomes. It could be 100,000, but you can still count them. Random, continuous, you can't count. So examples of discrete random variables are number of pets owned, numerical day of the month, or how many days of class you missed. Continuous would be things like weight, because even though you could be 162 pounds or 163, you could be 163.5. You can always find a number between those that somebody could be. So it depends a lot on how exact you measure things. But weight is continuous, as is temperature and time. The last thing we're going to talk about real quickly is personal probabilities. And that has to do with your belief that an event in question will happen. So it's a personal belief, it's a judgment call. And we assign probabilities kind of when it's not feasible to observe outcomes, when you can't see a long series of trials, see what the trend goes towards, and be able to see what the theoretical probability would be based on that. So examples of that are the probability that an experimental surgery will be successful. You have no data to see how successful it has been. So it's a personal probability. It's a personal judgment call. The probability that a defendant is guilty. The probability that you will receive a B in this course. You're starting to get some information about that, but you haven't taken this course before, so you don't have a lot of data to go from to see how often you're going to get a B. And the probability that your favorite baseball team will win the World Series in 2020. So those are all things that you look at your personal beliefs and judgments, and you make calls about the probability based on that. So we call those personal probabilities.